we have to see about characteristics of hydrocarbons. What are the characters that is presented for hydrocarbons? Okay, first we go to see here. First point is lower hydrocarbon, that is for carbon 1, carbon 2, like that. That is lower hydrocarbons are gaseous at room temperature. Example, methane, ethane, or other gases. Okay, you know very well methane. It is a mangrove forest gases. You know very well. In biogas also methane will be presented. So methane is a gaseous substance. Okay, next there are colorless. Second point is there are colorless and odorless. It does not having any color or smell. Okay, next the boiling point of hydrocarbon increases with increasing in the number of carbon atom. What is that increasing of carbon atom? That is CH4. Next alkane is C2H6. Like that the carbon will be increased. From that increasing in carbon, the boiling point also increases gradually. See here, you know very well methane. CH4, that is next C2H6. This two it having the difference is CH2. You subtract this one C2H6 from CH4, you get CH2. The same way these two you subtract, that is C3H8 you minus C2H6, you get again CH2. The variation will be similar. So gradually the boiling point will be increases in hydrocarbons and it increases down the alkane, alkene, alkyne, etc. Whatever the carbon compounds, it will be increases in a gradual manner. Okay, next we go to combustion. All hydrocarbons are combustible substance. Why? Because it contains carbon. A hydrocarbon contains hydrogen and carbon and sometimes oxygen, combines with oxygen to form a carbon dioxide and water, whatever it may be. It may be alkane, alkene, alkyne, or alcohols, aldehydes, ketone, carboxylic acid, ester, ether, that are made up of carbon. It goes combustion reaction to give carbon dioxide and water molecule, sometimes along with heat and light energy. You get the general formula, that is C is anything, that is C is X and X, H is Y plus O2 gives CO2 plus H2O. I give one example, that is CH4 plus 2O2 gives CO2 plus 2H2O. Okay, why we are putting in front of O2 2 and H2 in front of 2? Because it is a balanced equation. Before that you going, what is balanced equation? The reactants and the products will be similar. So that wise we are balance the equation. Okay, next. See here formic acid. I give another two example also. First one is formic acid. See here HCOOH plus O2 gives 2H2O plus 2O2 because it gives only H2O plus CO2. You have to balance this equation. How many carbon and how many hydrogen and how many oxygen will be formed from this HCOOH and O2. You have to balance it. That's why we are putting these two and this two and this two also. Already I say how to balance the equation. Here also heptane I given another one example. It is a alkane. The carbon number is 7. You have get the form. You know very well heptane. It is ended with ane. So alkane. Alkane general formula CN H2N plus 2. Here carbon is equal to 7. You put 7 means C7 H7 2 into 7 plus 2. See here C7 H 7 into 2 14 15 16. So C7 H16. See here it is correct or not? Yes. Heptane C7 H16. So it addition with oxygen to form H2O and CO2. You have to balance the equation. So only they put here 11, here 8 and here 7. Okay. Next, what is combustion? Combustion means you know very well, it addition with oxygen. Methane, they have to give the balanced equation. See here, one carbon, here also one carbon. How many hydrogen? 4 hydrogen. Here 2 hydrogen. So you have to balance this equation. In front of this one, you put 2. 2 2s are 4. Okay, next here 2 oxygen, here 2 oxygen, and here 2 oxygen. This 2 is applicable for hydrogen and as well as oxygen. So 2 2s are 4, but here will be 2. So in front of this oxygen you put 2 means you get the equation. So I write it here. The balanced equation is CH4 plus 2 O2 gives CO2 plus 2H2O. It is a balanced equation. Like this only you have to balance it. Okay. Next, alkanes are least reactive when compared to other classes of hydrocarbons. What is mean by other classes of hydrocarbons? That is alkene, alkyne, that is alcohol, aldehyde, ketone, carboxylic acid, whatever it may be. Alkanes are least reactive. Why? Because the carbon and carbon hydrogen, it are in a single bond. There is no double bonds. That's why it is least reactive. Okay. Reactivity of hydrocarbons. Alkanes are generally less reactive than alkenes or alkynes. Aromatic compounds are more reactive than alkanes but less reactive than alkenes and alkynes. I give the reactivity series, that alkanes, aromatics, alkenes and alkynes. Okay, this series you must know it. In higher classes you have to study this for your competitive exam. Okay. Next, see here, reactivity of alkanes. Alkanes have low reactivity for two reasons. One is carbon-carbon single bond and carbon-carbon carbon-hydrogen single bond. It is a strong, therefore it takes a lot of energy to break them. So it does not break the bonds. Whenever it will be break, it will be joined with other element. So there is no breakage. Whenever we give more energy to that one, then only it can be breakdown. So it have a less reactive. Okay, next, alkanes and alkenes are unsaturated hydrocarbon with at least one double bond, which is a pi bond. That bond is known as pi bond. You know in higher studies what is pi bonds and sigma bonds, where alkanes contains only sigma bonds, as sigma bonds are stronger than pi bonds. Alkanes are less reactive than alkenes and alkynes. This is the main reason. Okay, next, alkynes are the most reactive due to the presence of alkynes. See here, alkynes, because it having carbon triple bond. So alkynes are most reactive due to the presence of triple bond. This bond can be easily break down with low energy. It combines with any other element. Okay. Next, hydrocarbons, large family of organic compounds composed of only carbon and hydrogen, that is saturated and unsaturated. So alkane single bonds are saturated and double bonds and triple bonds are unsaturated. How can you identify whether the solution is saturated or unsaturated? We having test. That test is known as bromine test. See here, okay, that I explain. Like dissolves like, this means that polar solvent can only dissolve polar solute and the non-polar solute dissolved in non-polar solvent. Water is a polar and the hydrocarbons is non-polar. So hydrocarbons are insoluble in water. Okay. Next, to test for identify the saturation and unsaturated hydrocarbons. Okay, how it will be tested? To test whether the hydrocarbon is unsaturated or saturated by using bromine water, which involves in the addition of bromine water to the hydrocarbon Unsaturated hydrocarbons are decolorized. The bromine water color is orange in color, whereas saturated hydrocarbons will not decolorize it. The actual color will be presented as it as, that is known as saturated and unsaturated test. Okay, now you take one test tube and the given solution will be taken 5 ml and pour 2 or 3 drops of bromine water. Whether the color will be decolorized, that is bromine water color is orange in color, it decolorized means that is unsaturation. The color does not changes, the color will be remains in that solution, mean that is saturated. Okay, see here, two test solution will be given. One is alkane, another one is alkene. Alkane having single bond and alkene having double bond. So it is saturated and this one is unsaturated. Whenever you put the bromine water, see here, there is no change in color, but here the color will be decolorized. So alkane is a saturated and alkene is a unsaturated. You does not know the given solution is saturated or unsaturated. Here I given one example, so that's why I say this one, but in test they does not say the saturation or unsaturation. You have to test it by using the bromine water. Okay, that's all. Tomorrow we will see with another new topic.